Now we are going to do the questions of this chapter. So all these questions you also do in the notebook. Okay, so this is one index question. Question is, first question, predict the products formed. Predicts the product formed. First one, CH3, CH2, CH2O, CH3 plus HBr. So we have done this already. This is either on treating with HBr or HI, what will happen? This oxygen OR bond will break. Okay, so you can see, so I gave you 2-3 tips for that. Here you can see both the side of oxygen, both are primary alkyl group. So I told primary alkyl group, both the side primary alkyl group means halogen will add with small group because the mechanism is by SN2 mechanism. Okay, so here CH3 with the Br and the remaining always oxygen will take hydrogen. So what is the product? CH3Br plus CH3 CH2 CH2OH is the product. Now second one, this is benzene with OC2H5 plus HBr. So here also, here it is benzene, one side of oxygen is benzene and the next side is ethyl group. Okay, so this is bulky group and this is small group. So what will happen? Br will add to C2H5 and oxygen will take hydrogen. And more than that, we know that benzene oxygen, this bond you cannot break because this bond is strong. Almost double bond character is there. So this bond you cannot break it. So C2H5 with the Br. So the product is C2H5 Br plus benzene, that is OH. Phenol is the product. Now third one, next one is again ether, benzene with OC2H5. They are treating with the concentrated H2SO4 and HNO3, concentrated HNO3. So we know that this is nitrate mixture. NO2 group will substitute on the benzene, and here OC2H5 is there, ortho position. This is ortho para directing group. So ortho position Br can attach or not Br and NO2 can attach, and para will be the major one because we know that this one, if ortho it is coming here, it has to come. This is para NO2, this is para plus ortho also can form. So ortho is this OC2H5 in the second position and NO2, this is ortho, and we know that para is the major product of this. Okay, now fourth one is CH3 thrice C OC2H5 plus HI. Okay, so this one you can see one side of oxygen is primary, next side is tertiary. So if this is the case, we have discussed already, I will add with tertiary because the mechanism completely it will change. Mechanism is by SN1 mechanism, therefore I will add with this one. So what is the product? CH3 thrice C I plus C2H5 OH is the product. Okay, so now second question is write the reactions. Next one is which of the following is an appropriate set, of reactants, appropriate set of reactants for the preparation of 1-methoxy 4-nitrobenzene. Okay, so what is the product is 1-methoxy. Methoxy means OCH3 and fourth position NO2 group. This is the compound. Okay, 1-methoxy 4-nitrobenzene, and they have given this they have to prepare, and they have given two this thing. First they have given this one Br NO2 they have given, plus CH3ONA they have given. This is first set they have given, and second set they have given CH3Br plus this one is ONA and NO2 they have given, and they are asking 1 or 2 which one is appropriate for the preparation of this. So we have discussed already in Williamson's synthesis, this primary, this is oxygen is there, and you have to always consider oxygen is the functional group. One side of oxygen is CH3, next side is this bulky group is there. Always the small group should come from alkyl halide RX, that is alkyl halide, because the mechanism is by SN2 mechanism on RX, that is a preparation. So here this one you can see this alkyl halide, this is the alkyl halide. Okay, this is bulky group, this is not possible for Williamson's, and this one you see CH3Br plus this one, this is possible because the mechanism is by SN2. So this should be this group alkyl halide should be primary alkyl halide. So this is the preparation. Okay, now next questions. Now question number 3. Question number 3. So write down the questions. Question number 3. Write the names of reagent and equations. Names of reagent and equations for the preparation of following ether by Williamson's synthesis. By the Williamson synthesis. First one is 1-propoxy propane. So what is this 1-propoxy propane? CH3 CH2 CH2 propane. Propoxy, so 3 carbon, CH2 CH2 CH3. This is 1-propoxy propane. So how can you produce by Williamson synthesis? So we know that Williamson synthesis, alkyl halide and sodium alkoxide. So both the side is primary, both same length, no difference in the size of alkyl group. So you can use CH3 CH2 CH2 Br plus CH3 CH2 CH2ONA. Okay, so this is the one. Now second one, ethoxybenzene. So benzene is the ethoxy, OC2H5. This is ethoxybenzene. So one side is C2H5 and one side is benzene ring. So what you have to do, C2H5 should come from primary, C2H5Br plus benzene ring with ONA is the product, ethoxybenzene. Now third one is 2-methoxy 2-methyl propane. 2-methoxy 2-methyl propane. So propane is there, CH3 CH2 CH2, okay, and 2-propoxy 2-methoxy. Okay, sorry, I'll write the compound. The compound is 2-methoxy 2-methyl 2-methoxy 2-methyl propane. 2-methyl propane. So propane is CH3 CH2 CH3 is propane. Okay, but 2 second carbon here instead of 1 hydrogen, methoxy OCH3 will come, and instead of this hydrogen 2 on this second carbon carry methyl group also. So this is the compound. You see the compound, you see. So I'll write once again the compound, CH3C CH3 CH3 OCH3. This is 2-methyl, 2-methoxy, 2-methyl propane. Now we can see oxygen is there. One side of oxygen is this group. Next side of oxygen is this group, and we know that this is tertiary and this is primary. If this is the case, Williamson's always we have to remember tertiary group always come from alkoxide ion, and this is come from primary alkyl halide. So what is the product? The reagents are CH3Br plus CH3 tertiary alkoxide ONA. This is the reagent. So using this reagent you can prepare this compound. Okay, now next one, fourth one is 1-methoxyethane. 1-methoxyethane. So ethane, what is ethane? CH3 is ethane. Then first carbon carry methoxy. This is the compound. Okay, now oxygen, one side is CH3 and one side is CH3CH2 group. So always the small group should come from alkyl halide because the mechanism is by SN2 mechanism. So CH3Br plus CH3CH2 ONA is the reagents. So these reagents, if you react, then you will get this product either will be produced. Okay, so this is the next. Now we will do the next question. We'll do first we'll complete the ether questions, then we'll go to alcohol. So many questions are there for alcohol also, and here they are asking next question is they are asking the question, write the equations of the following reactions. So third question over. Now fourth question we will write. They have given this and all, you write down the answer. Okay, write the following reactions, write the equations, write the equations for the following reactions, equations for the following reactions. First one is Friedel-Crafts. First question is Friedel-Crafts reaction, alkylation. Friedel-Crafts alkylation of anisole. Friedel-Crafts alkylation of anisole is the first one. Second one is nitration of anisole. All this we have just now we have done all everything. Nitration of anisole. Now third one is bromination of anisole. Bromination of anisole in ethanoic acid medium. Bromination of anisole in ethanoic acid medium. And fourth one is Friedel-Crafts acylation. Friedel-Crafts acylation of anisole. Friedel-Crafts acylation of anisole. This is everything just now we have done. Find out the answers and do it. Okay, now next question, question number 5. How can you synthesize? How can you synthesize the following alcohols? The following alcohols from alkene. How can you synthesize the following alcohols from alkene? The first one is alcohol is cyclohexyl group is there, then CH3 and OH. So this is the alcohol. So they are asking from which alkene you can prepare this. So what to do? We know that alkene to alcohol we can add water. So corresponding alkene they are asking what you have to remove water. That's all. Remove water. So here this carbon carry OH group, and the adjacent carbon you can take hydrogen. So this OH group on this carbon, this OH group is present. Now adjacent carbon you take hydrogen. So this carbon you can take hydrogen. This is the adjacent carbon, or this carbon you can take. This is the adjacent carbon, or this carbon you can take. Okay, so if you are taking hydrogen from this carbon, what is your product? You are removing water. Okay, minus H2O. Minus H2O means you can use concentrated sulfuric acid. You can use the reagent. So you take H from this. So here double bond CH2 plus. Now next chance is there, you can take from this or this. If you are taking this or this, similar same product only will get. Okay, same product only will get. Anyone you can remove. So I'm going to remove from this. So what you will get, cyclohexane is there, this OH is removed, and this is CH3 and H you have taken from this carbon. Here the double bond will come. And according to Seytzeff rule, we know that this double bond is towards end of the carbon. Therefore, this is minor, and this is almost the center of the carbon. Therefore, this is the major one, and this is the minor one. Okay. Now, next one is, second one is like this. Okay, and the center, this OH group is present, and like this also one group is present. So here this is methyl group actually. If the group is there, means here carbon is there, no, this is methyl group. And if you are removing minus H2O, you are removing water. Or for removing water, you can use concentrated. Sulfuric acid is the best dehydrating agent. You can use that. And this is the carbon carry OH group. So adjacent carbon, you can take hydrogen, and this is one of the adjacent carbon. This is adjacent carbon. This is adjacent carbon. So I told you before, if you are removing hydrogen from this or this, you will get same product. Suppose you are taking hydrogen from this is methyl group actually. You are taking hydrogen from this and OH from this carbon. Your product will be like this. You are taking this one, no? So your product will be like this. Okay, so you are taking H from this and OH from this. Now another chance is there. If you are taking hydrogen from this, then what will be your product? How many? 1, 2, 3, 4, 5, 6, 7 carbon is there. 1, 2, 3, 4, 5, 6, 7 carbon is there. Here center. If you are taking hydrogen from this, then you will get the bond like this. Or if you are taking this one will be like this only. And if you are taking hydrogen from this carbon, instead of here, double bond will come here. And which is the minor? This is double bond is towards the end of the compound. This is minor, and this is the major one. So like that you can do. So if they are giving the alcohol and corresponding alkene, if you want to find out, what you have to do, remove water from this. Okay, so take OH from one carbon, adjacent carbon, you can take hydrogen. Like that you remove water, so you will get corresponding alkene.